So today I want to share with you some of the experience that we have been building inside GitLab when we started working with the data science team. And the main question was, how can we take our machine learning experiments and escalate them in a way that we address lots of problems that we usually encounter when it comes to how to reproduce an experiment, how to time to market, and so on. So I will elaborate more on that. My name is William. I am a developer advocate at GitLab, and I also work with the data science team. My background and education is in machine learning from academia perspective, and now I had to learn, like 7 years ago, I had to learn DevOps, basically, to be able to escalate the things that I was doing for fun or as a hobbyist or in the academia. So this is, there are many things here that are very opinionated. I just want to show you some fundamentals, and that if there is something here that resonates with your use case, it can be used. This is a field that is in, I will say, in some sort of self-discovery. We are finding things from DevOps that can be used in MLOps and so on. So bear with me in this journey. So let's start with this. This is one application. That is a banking portal that we were playing the other day for a customer. So you can see that this is the typical thing that this is a prototype, of course. I have here a mortgage calculator and so on. And now let's consider that when I click here and sign on, I want to use my credentials as an employee to go to some sort of dashboard that I can see, for example, the performance of a model that is in charge of doing detection of fraud using an open source data set. It's a synthetic data set that I found in Kaggle. This application will help me to tell the story about the fundamentals of how we can escalate this type of workloads. So now you can here imagine that, let's say I want to use these inputs, and I want to say that using these features, I want to calculate the probability that something is a fraudulent transaction. So let's say that I say this is the distance from home, 0 purchase rate, and the person who was doing this transaction used the PIN number. And now what you see here is that when I click on predict, what I'm doing right now is querying a model right now. So this is an online, let's say, prediction. What I'm saying, I'm passing certain features, and I am hitting an endpoint that has a trained model, and it is telling me that the probability that this is a fraud is almost is very certain. It's 0.999%. So 99%. So we see here that this application and this banking portal is what we have been discussing in the industry, saying like I have a microservice architecture where I have some sort of web application that is connected to different backends, and one of those backends in this case is a UI that is connected to a machine learning model that offers different things. It can be analytics or some sort of report that I can see as a dashboard, or I can query the model directly. So this is part of the dashboard that the internet has been not helping me, where I can see the batch processing. So in this case, what I had two things. One, where I have a dashboard with a lifetime of different transactions and batch processing, and the one that I was doing more in live is, okay, let's try this model by changing these features and let's see the prediction. So let's say that we can agree that more or less a very high level architecture of this portal can look like that, where I have different microservices and one that consists of the backend of a fraud detection model that can do online and batch predictions. And now if we focus our attention on this one, we can say that this is a machine learning pipeline that is behind that specific service. So this is a very high level one. Again, this is just to help me to tell the story, but I believe that we can agree that from a high level perspective, these are part of the steps that we have to do. We have a data source, in this case, let's say a database with different transactions, and I have to, like it or not, do data cleaning, data annotation, feature engineering, modeling, and go back to data annotation, feature engineering, and modeling. So this is a cycle that is highly iterative, and this is where we start drifting from the different practices that we have learned in DevOps. In DevOps, in regular software engineering, you write code, you deploy, and this code will be there for a certain amount of time. Here, as you can see, when I was testing the model, we can bring someone with domain knowledge, and they can say, you are not using certain database that can be relevant to do the prediction. Or I saw that when we were testing the model, it was biased, or it didn't make any sense. So then is when it comes the lots of whatabouts. so far and in the academia or when you start playing with these things is that, yes, I created a model, I created an endpoint, I deployed, I use cloud native applications, and good. But then in real life, there comes all the whereabouts and is, what if we need more feature engineering? What if we need to iterate on this pipeline and choose better features for prediction? Or we train the model, and that's barely the end of it. This usually requires constant training and retraining of these applications. And to create several releases of the same artifact that you saw is the model. And someone can say, we have maybe another model architecture, or we have more data. How can we train this thing to see if the performance improves? And one of the main is that how can review these results and reproduce them. This is one of those, there is a paper from 2015 that is called the Technical Debt of Machine Learning Systems. Already in 2015, there was teams that were working with this saying, it is kind of easy when one person starts and they do this in their computer, but there is a lot of glue code and lack of standards, and when we need to not collaborate just as one person, but with different data scientists or machine learning engineers, it's very hard to reproduce the results. It's very hard to even onboard. It's already a challenge to onboard a developer. Now imagine when you need to onboard a machine learning engineer. We faced this challenge at GitLab when different people were creating their own environments. Someone like Virtual M, some other ones were coming with Miniconda, others with Anaconda, and all of this mess of different things that it works here, it works in my Jupyter instance, but I can barely make it work in someone else's computer. So all of these things, they ring a lot of bells, and these are many of the challenges that the DevOps community found like in 2005 or 8. And we are now saying, what can we do to not repeat the same mistakes, and how can we leverage standard practices and start discovering what we can do to address these challenges. So one of the things that are a lot, but I wanted to focus on some of them, that imagine the what about, that someone comes and says, we need to do further pre-processing and feature engineering, train and retrain a model, test new architectures, and review and reproduce results. This has to be done fast and compliant. That's one of the main things that I hear all the time when we are working with this. And this is where we see, okay, there are many things that we can reuse from DevOps in order to address these two axes and solve these problems. But not as a single person, which is something that can be done today. If I was working alone, I could do all of these things, and I could come out with a report and tell my manager or tell the business users, look, I created all of these things, and here is my output and report. The key here is that we need to do this at scale, like many machine learning engineers, and faster. So how this process, this machine learning pipeline that is quite simple, should respond to those changes, to the what about if we need to do this and that. So let's say that now in this presentation, let's divide and conquer, and let's go through different use cases when I want to show you what is that we have been doing and how developer workflows in the machine learning engineering realm can speed up and address some of these challenges that I illustrated here. So the answer, and all of these things that I'm saying, can be wrapped in the MLOps realm. And here, this is an ongoing discussion that is MLOps, is DevOps on top, or is DevOps on top MLOps? I'm not going to enter into that. I just want to tell you that using MLOps principles, we are solving many of these challenges in different use cases. So the first, scaling machine learning experimentation. So one of the main differences with traditional software engineering is that machine learning is highly iterative. You have to do a lot of things, test all the time. And sometimes it's just, let's change one parameter and see what happens, and then compare scores and so on. So one of the things that I found here, imagine that when we embrace developer workflows, is that let's assume that I was tasked with changing something in the model, which means, I don't know, let's get a different split from the training data set. So here I start using what is called a developer workflow, but oriented to a machine learning pipeline. So I'm going to create a merge request, and what it means is that I'm going to add some code changes to the code base that will interact with the data, and it will create a new artifact. And that artifact, in this case, is the model. So I'm going to use the Web IDE here to add those changes. And if you recall, part of the issue was saying, let's change the split of the training data set. So I come to the source. There is a script here called train model. And right now the train data size is in 0.7. Let's use 0.9. This is a very small data set, so should be OK. So now I added a change, and I am committing it to a branch. And when I go to the merge request, here is where this part of the magic and this thing that I mentioned at the scales, it starts to show up. As you can see here, I made one change. I am iterating in the model. I am changing one hyperparameter. And this trigger a pipeline that in this moment is doing several things. It's training the model. And to train this model, is pulling a Docker image that has the dependencies that, as a team, we agree are the dependencies that we need. So with this, we start already having some standard that will help us to be less into the dependency management hell. Then there is a test phase, where this is a very interesting thing because testing software engineering is usually unit testing, like considering certain edge cases. If there is file, there is no file, try, except, and so on. In this case, the pipeline can be all green, and still it doesn't work, because the model can run, it can train, but if the performance or evaluating the model tells me that the accuracy, let's say in this case of detecting if something is fraud or not, is not good enough. So the pipeline can be green, but the model is not good. So how do we know these things? So traditionally, and the things that I encounter with customers or practitioners, is that you have to come here. And many people that know how to bring something from Jupyter Notebook to production knows that this thing is very hard to reproduce. But still, this is the place where data scientists work. So this will take some time. So for that reason, I created another merge request that I already finished. And it's this one. So it will help me to illustrate what I'm telling you. So we see here different things, that the pipeline finished, it tested, and it created a compliance and review environment. Here you see that automatically, when I was testing the model, inside the script, there is a line that is saying, you pull the data, you do your data processing, feature engineering, you create an artifact, there is a model, and then you test it with the test data set. And that will call the method to predict. This will generate, in this case, very simple illustration. It can create among different things a confusion matrix. So in the past, when we wanted to see this, I had to spin up my Jupyter Lab instance, load the notebook, and hope that we all had the same dependencies and that this was going to run. In this case, I am abstracting from all of those things, and what I'm seeing is that the things that matter to me as a data scientist is this performing or not? What is the accuracy? Even if the code is not that great, I just need to know if at least this part works. And here you see that in terms of collaboration, I can add reviewers. So here it goes beyond code review. I can add a reviewer to say, OK, now you will review also the code, but you will also review the performance of this model. And everything here in a merge request, which already start giving us traceability of there was a branch, there was an issue. You saw that I opened an issue. There was a merge request. And this specific version of the model generated this report. So now we have this sort of traceability. And one of my favorite applications is this one of compliance and review. You see here that if I click here on View App, this will bring me to another application that is running a library that is called Deep Checks, and it creates a full suite of testing that goes beyond the regular testing in software engineering. This can tell me, for example, different things that it does automatically. So one of the things that you have to do is you take your model and you put it in a way that you pass it to this library with your data and your test and training data. And this will generate a lot of testing, and it will tell you not only if the model works, but also how is the performing. So there is one thing between testing the model and evaluating the model. So here we are evaluating it. And one of the reasons that I got to know this library is because recently, I don't know what happened, if it's still, but there was an AI enactment regulation, something that will come into, that we will have to do something about it this year. That's why I don't remember when. And I was checking that this library, for example, this one, if you see here, didn't pass. This very simple model didn't generate any alert. But I wanted to show that There is another open source data set that when you test this one, and it tells you, for example, what were those tests that didn't pass, I found this one very interesting, the weak segments. Because are you familiar with what is the weak segments performance? So I will tell you why this is so important, and it is a test that didn't pass in this case. It's that you have a data set, and you create different subsets of the data set. And then you test your model in different subsets. So if there is a subset in which it performs very well and in others very poorly, it can mean that your model is biased. And this is very important in highly regulated industries and also because of fairness or ethical concerns. This could be an application that says, should I lend money or not? And if it's performing well in different subsets, but then there is one in which it doesn't, it might mean that you might be not being fair with certain segment of the population. So as you can see what I was telling you, the pipeline can be green, but this can bring a legal liability or fairness or ethical concerns when your model is not necessarily performing equally across different subsets of the data. So you see that all of these things that I'm showing you, they are happening here in a developer workflow. But in this case, it's highly flavored to machine learning workflow. We are analyzing a model with code and seeing what happens and what are the type of results that it generates when I evaluate the model in these different steps. So training, testing, and compliance and review. And then going here and seeing different iterations of the model. For example, I changed something 1 hour ago, and then it generated, again, another confusion matrix. Very easy to get started. And going back to the challenges that I mentioned, there was a presentation before I saw from NVIDIA. Have you tried configuring a GPU card? Anyone? It can be challenging, right? So it was detected as one of the main problems that, imagine that engineers sometimes struggle with this. Now you come to someone that studies statistics and you tell them you have to configure this cluster with GPU. It can be already a long time to get it done. So one of those problems is that people that know more about data processing and working with data, they don't necessarily have the expertise to do all of these configurations and allocate this hardware. So one of the things that I wanted to highlight is that in that paper, one of the challenges that was highlighted was the allocation and configuration of high-performance hardware. So as a data scientist, I don't really want to do that. I will do it if I have to, but I don't want to spend my time dealing with these things. So one of the things that we see by using CI is that this wasn't necessarily the reason why it was invented. They were just saying, look, if you are using CI and GitLab runners, you can add some tags that will choose certain type of machine for different workloads. So then I saw that there is one that is GPU enabled. And what we did is that we said, OK, there is something that is already allocated a GPU and GitLab is maintaining it for me. Let's just use that one and run the training only there. So in this pipeline, only this one, the one that is in charge of training the model, I just put this NVIDIA SMI there for illustration purposes that this machine is GPU enabled and that all the training that is happening here is happening faster because of this GPU. And as a data scientist, I didn't have to do anything. The platform engineer person added this tag into the YAML, and the only thing I have to do is what you saw, changing some hyperparameter, running a pipeline, and this gets automatically allocated. So here, we see another situation or moment in which it is making my life easier, more efficient, and even happier, because I remember trying this, and I am very happy to not necessarily have to maintain the drivers of the GPU card. So this is in that moment of this architecture when we said we need to scale experimentation. How can we do this faster? And I already showed you one part where we can automate hardware allocation, and that, as a result, can help me to have faster iterations. It happened, and this is not exaggeration. We had in my team people that were saying, I have to run this in my computer. I will leave it on, and I'm going to write a script that will keep moving the cursor because I don't want the screen to go down, because then the training will stop in Jupyter Notebook, and then I have to restart, and I already spent 4 hours. So now I can push these changes to the SaaS runner, close the computer and I don't care if the computer goes to sleep or not. That's one of the things, little things that make life easier and happier. So now, testing and review. This is the chapter I was showing you, all those toolings where you can use libraries that help you to find biases and fairness in algorithms. But there is another thing, and I bet many of you are familiar with MLflow. Are you familiar with MLflow? MLflow is an open source library that helps you precisely to navigate that highly iterative nature of machine learning, where you try a lot of things and you choose the one that works. So that library was built for that. And they have some concept called experiments. And as you can see here, we created, as part of the MLOps features, where we are extending, this is DevOps, but now we need MLOps. There is one feature that is called model experiments. That what we do here is that I create an experiment in my script. In this case, the experiment is called fraud detection. And here you see all the different attempts that I was doing when I was training the model. Why is this important and cool? Because let's choose the latest one that was created 7 minutes ago. In the past, when I will tell you, this is a joke actually. Let me see if I have it here. Have you seen the joke with the Untitled 1, Untitled 2, Untitled 3? That people say, what is your best model? And you have to open all the Jupyter notebooks to see what was the one that had the best accuracy. So here, instead of doing that, I come here and I see, okay, we are logging the score. So I just choose the one that has the highest score, and this is the best model. End of story. I don't have to go through different Jupyter notebooks to find what was the best. And now, with respect to the collaboration and traceability and being able to take it out of my machine and making it work in others, so you can see here that, as an example, this one was the one we did, where I changed something. So we see that there is some metadata associated. It says that this person created a merge request, and that merge request resulted in some model that has this accuracy. But what is cooler is that when you click here in artifacts, it will use the package registry of GitLab to register two things, the actual model and the requirements file. So here, this is not necessarily the silver bullet of that, but this is increasing the probability that if someone wants to replicate my experiment, at least they can install the same dependencies and load the model that I created. And if we all follow the Docker image that we agreed that we were going to have with the Python version, you will be able to load this model and work with it in your computer. This was i5 at least 3 years ago. This wasn't that easy to say, okay, I want to replicate your experiment in my machine and also his experiment. No. So with these applications, with these features that come from having different practices from machine learning and putting them into the workflow of software engineering, we get these things. In software engineering, this is called an artifact. In this case, it happens to be a model. But it's, at the end of the day, a binary that gets created as a result of the interaction between code and data when we train the model. So this is another way. So you saw that when we use model experiments tracker and we embrace developer workflow using merge requests or pull requests, however you are more familiar with it, we start like being more standard and making it easier for our future self or other team members if they want to work with this. So now, this is another one that is very important. Let's say that we are happy with our code and architecture. What we need to do is to train and retrain automatically. Why? Because there is new data. So you need to generate another artifact. So here is where we also found another thing that is pretty cool from DevOps, which is the schedule pipelines. So you see here that there is an option where you can have pipelines and the scheduled ones. So in this one, you see that we have a pipeline. This is from an actual production system where we are doing a scoring of a propensity model. And what we are doing is that we said, we found out that every week the data changes in a way that is considerable to retrain the model. So I don't want to, as you saw, I was showing you first that as a developer, I changed something in the application, and then this triggers a new model. In this case, we are happy with the application, we just have new data. So I don't even have to do all of these things anymore. I can just schedule a pipeline that will run and will create another artifact, and that artifact is the new model. And because we need evidence of that, we can use another thing that already exists in GitLab, which is the old and good wiki. Who doesn't know a wiki? This is like perfect to document documentation for a project. So here we have, and this is some pilots that we are doing with that we said we want to take the job that ran automatically using the schedule pipeline. We want to test the model, create model metrics, and publish them into the wiki inside GitLab. And this will be the latest model. So then someone, a human, can come and say, okay, this is not good, or this is better than the previous model, and then we deploy a new version of the model to the production system. So we can automate all of these things, but we are afraid of doing that, so we always have someone that will say, yeah, this one, so click, deploy. So this is all those things that were always there, and we just found out that if they found them in DevOps useful, we might borrow some of those concepts, and we see that so far, when you search for MLOps ecosystem and system, there are lots of platforms. And one of the things that we are doing is, if you already invested time learning this, why don't we use some transfer learning and we learn few things at the moment, little by little, such as the concept of a model registry, the concept of bringing this accuracy and performance metrics into the merge request, and so on. So moving forward, this is how we are doing the training and retraining automatically. We found that we have scheduled pipelines that we can just run it in the main branch of the repository, and we generate a new artifact with new data. And now this one is very important, and I didn't know, actually I borrowed this from some customer, a bank, very large bank. They were calling it MBOM, and I loved it, because in software engineering they call it the SBOM, for the software bill of materials. And when I was showing them this, when you come here to secure and dependency list, this view, as you can see here, is called SBOM. It has all the packages, all the dependencies that generated the production artifact, or in this case, the model. So this application that you saw me clicking things and predicting if it was fraud or not, was built using these dependencies. And then I learned that they just changed the S for M, because that project in a specific was for creating a machine learning model. So for them, this is the MBOM, the model bill of materials, and then you can export this thing in a JSON file and put it into our systems for auditing or so on. If you need if you have to, for certain regulation, you have to explain these predictions were done with these packages and this traceability. Here is the set of dependencies that led to that model, that led to those predictions. So again, we see here different things that existed already there and that we can use. And we will not necessarily go in depth into this, but you can see that GitLab also helps me to find security vulnerabilities in the dependencies that I'm using. So then I can bring a security architect or someone that knows about security and start working on this. And I will dig a little bit later on this. So with this, we start moving to the compliance and MBOM and different problems that we had and I wanted to address. So when we started doing this internally and with the different customers that I have interacted, one of the main pain points is there are a lot of manual steps. There are many moving parts that someone knows how to do, but we need to find a standard way to do that. So we enable a quick experimentation, and we are able to share models faster. I don't know if you heard recently, it was trendy on social networks, the term GPU poor. They were even making hats of that because everyone wanted to buy a GPU, but they are not available. So we had a workaround about being GPU poor by using the SaaS runners that already had GPU enabled that GitLab bought before. And then all these longer cycles of experimentation and train and retrain, we solved by using the schedule pipeline. So there were 3 problems, the what about, and we solved them using this, and we didn't, for the time being, we didn't have to buy anything new. We were just reassembling things that we had, and using GitLab built some features, such as the model experimentation tool to consolidate all the experiments in CI, but that was it. And now, this is, do you remember that I was mentioning the architecture in the beginning? So this architecture that I'm about to show, it became sort of a footprint that I've been using now, trying to be more, to make it easier to replicate and to have some standards. So this architecture has different moments. One where I have Git for the code and DVC for the data, to have data version control as well. with this locally, I can keep track of code and data, that they are separate, but they go together. They tell the same story when it comes to the model. And all that I show you about CI principles is doing the training and testing automation. And testing, recall that it goes beyond the unit testing, that it works, but it also involves the testing of fairness and biases. And then this specific part of training, we didn't want, and we don't want, to deal with GPU drivers and configuration. So this gets automatically allocated for us. And in test, we apply some security policies. For other projects that are more complex than this one, we apply security policies. So let me show you, for example, this one. This is similar. The concept is the same. It's a model, but this is more complex. This is an application that is using word embeddings to search using semantic search, that you put some description and it will give you some results. And you see here that in this one, we have a policy that says that if the code has if this static security scanner detects a certain vulnerability in the code, this cannot be merged into the main code base. I will need to fix it and get approval from someone that is capable of giving this so I can move forward into the main branch. I have a report of different vulnerabilities. I see here that in this case, I'm having one that MLflow certain problems, so I probably will need to update this library. And one of the things that I wanted to show is that in this one, this is a search engine, basically, that it looks nice when you put it in a UI. But when you are just testing it, you need to do the same things that I was showing. You need to try it, evaluate it. And here I have an example when I was evaluating this model. It's the same mark, that this pipeline generated this application. And this is just a temporal UI that I'm using to evaluate the model and make sure that beyond the code working, whatever results it is giving, it works. I recently learned in a Python conference that people working with these systems, they are calling this the vibe testing. That you don't have to be that systematic, just try a little bit here and there, and you say, yeah, the vibe is good, so I must okay-ish, and then you check. So I have certain prompts, if you will, that they're calling these days, that I wanted to test, and I say, okay, there are these ones that it must work, and if it doesn't, so there is something wrong with the model. So that's the vibe testing that I was doing with this one. And as you can see, the pipeline in this one is way more complicated. It has more steps. This first testing step is one that is taking this text box that you see here, and it's trying different attacks. It's trying putting some 0, 1 things to see if it can break the application. So at the end of the day, one of the things that I have learned is that if you come from data science or machine learning engineering, and you start adopting these practices, you also become a better software engineer, because I learned a bunch of things about security that I never considered when I was building a model. Now I have to consider them, because if the pipeline is not green, I cannot merge the model into the main code base. And similar here, you see that there are model metrics, and this is telling me that this cannot be merged. I have to fix this. So with this, I am also reducing the probability that I'm inserting any security vulnerability into the machine learning application. So this is security policies. And the accepted testing, I should change it to the vibe testing. This is deploying a model, trying it, and seeing if it gives something that makes sense, and then automatic or manual deployments. So the architecture you see here is something that I've been using as a footprint, that whenever we have some project, it could be an LLM, it could be a logistic regression, XGBoost, whatever, we try to follow this standard to at least make it easier to replicate in different use cases or by other colleagues. And because all of these things I mentioned, I learned to do first on my own, because I just wanted to improve the quality of my life. But then when I was using it at work, I realized that when it comes to better collaboration, this is where there are huge earnings. When you do these things, you just enable a lot of people to be on the same page and work at the same pace that you do. As a one-person startup, I didn't see back then the value. Now that I work with more people doing these things, I say, oh, this is super cool that you can just pull the container, pull the model, and you can try what I was doing without having to deal with Jupyter Notebook that much. And in our use case, with this and start to close, we started dog fooding, which is one of our GitLab practices. that we start small. We say, okay, we have this model that if it breaks, it will not be the end of the world. So how can we start doing and adopting DevOps practices gradually? And we did it in a way that is friendly with the data scientist. So in this thing that you see here, we are running a pipeline that gets triggered by a Jupyter notebook. That's like a sacrilege for software engineering, but we are doing it like that because it works for batch processing. My friend, the statistician, he's able now to just schedule pipelines, and he doesn't have to deal with all of these things, and we have a rescoring of the model every week. So the things I show you in the demo, different ways that we can collaborate. And this is the architecture that we have these days, where we have a data source in Snowflake, and we have a container registry with an image that is the standard image that all the data scientists we use. And we have a pipeline that runs automatically, pulled from Snowflake, loads data set, feature engineering, processing, metric reports, then it creates a merge request. Do we update or not the model? Yes, no, yes. Deploy to production? No, it stays in the MR, and then we close it. So this is something that we are doing right now with thousands of rows, and it works. And then I want to close by saying the sky's the limit. I also found out that there is this pattern called GitOps, where you can have in one project the UI, for example, and in another project you can have the model. And if you make one change in one or the other, and you need these two things to interact with each other, you can trigger what is called a multi-project pipeline and take two different projects and put together a full application that builds and gets tested and deployed automatically. And this pipeline that you see here, this is how this was built, the one that I introduced at first. All of these things are coming from different backends, and if I wanted to make a change and deploy and build the model, train and deploy everything here, I could do it using this pattern of multi-project pipelines following GitOps. So I want to close by saying that thank you very much for your attention, and that scaling these machine learning practices, adopting MLOps concepts will allow us, and is allowing us, to iterate faster and remain compliant. And this is one thing that I learned recently, that is that there is no MLOps without DevSecOps. Thank you so much.